Okay. Hello, everybody, and welcome to what is an extra stream for this week. I hope everybody is doing well. I know this was kind of unannounced. It was kind of a last-minute decision, but yeah, we're doing an extra stream this week. So, hoping to knock out some more of this asset stuff, and hopefully, make a bigger dent in the progress of this tonight. So that is the goal for tonight. We'll go over that in a minute, as well as a couple of other things I want to touch on. But before I touch on anything else, I do want to take just a quick second and thank the supporters of the channel listed here on the screen, starting with our partners, who are the highest tier of subscription over on YouTube memberships and Patreon. I would also like to thank all the other supporters listed here under the supporters section. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated, and it helps me with covering costs of the channel, the project, equipment, things of that nature. So thank you all very much. I greatly appreciate that support. And of course, I hope it goes without saying that I do appreciate each and every one of you viewers, whether you're here on the Twitch side or you're on the YouTube side. I have the chats up on individual monitors here so that, I can see them both at the same time. We do simulcast to both. So if you have something you want to chat about, feel free to jump in the chat, say hi. And, I enjoy interacting with you guys. So I will answer any questions or whatnot to the best of my ability. Tick Tick Boom, how's it going? Good to see you. Ruche, thank you for the Spiro high. I like that one. All right, so what we're going to do tonight is a little bit of an extension of kind of the stuff we've been talking about here, having to do with assets and asset loading, lifetime, all that stuff. And it's kind of the same thing we've been working on for the last, I think, 2 streams. And we're going to continue it. But it's we're going to talk a little bit about where we've come, at least off camera or off stream, and where we're going to go, because there are some modifications to this, and I am working on redoing this to make it a little bit cleaner. But I do want to just take a second and back up so that we're kind of clear as to everything that everything that is going on with this. So when we are talking assets, we're talking about the item that's loaded off of disk, right? So you have, let's see, let me get this. So you have resources, which, can I add text to this? I should be able to. There we go. Let's see, let's make a larger font here. So you have resources, right? So things like your textures, static, meshes, terrain, skybox, etc., right? These are the things that wind up getting loaded into the world, right? And each one of these are backed, oops, don't want to change the color yet. Each one of these are backed by an asset, right? So for example, if we want to talk about an asset, let's say static mesh, right? A static mesh asset, right? There's a couple of representations for this. There is, first and foremost, oops, I keep changing the color first. There's a couple of representations of this, right? So we have our, what we're going to consider our binary asset, right? So that's going to be our binary asset. And this is a .ksm file, right, for kohi static mesh. So we'll color that one green, right? And then we have another representation of that same type of asset. That is a, we'll call this a source asset, right? And this is a .obj file, or a wavefront obj, right? And actually, instead of saying binary asset, let's say primary asset, right? So you have a primary asset and a source asset in this case, right? And both of these are represented by a static mesh asset. So the way that this works is there's a process that these go through to be loaded off of disk or from a package or wherever they're loading from, right? That's irrelevant for now. We'll come back to that. So the way that a primary asset works, right? This is an asset that's already been sort of converted to our native format, is it just goes through a binary static mesh serializer, right? And then that's what gets read into the static mesh, right? So if we think about the sort of flow of this, if you will, we have the primary asset goes into the binary serializer, right? And then the binary gets loaded into the static mesh. The static mesh, then, the asset static mesh, is what the resource then loads into eventually GPU memory, right, to be rendered on screen. Okay, and then if we think about the source asset, if you know anything about Wavefront OBJ, it actually contains a second file that goes with it, which is a .mtl, right? And so an MTL is a material definition file, right? I think they call it material template library. And so the way that this has to work is there's an additional step in here. So the way that this works is we have, at this level, we have a serializer for each. Actually, I'm not going to group these into two. Let's make them separate, right? So we have a serializer, right? Let's change that to blue to make it match this other guy, right? So each one of these has their own type of serializer, right? These serializers are used by let's see, I should probably put this here. Whoops. Serializers are used by new color, an importer, right? And this is going to be a static mesh importer. Now I know you're thinking this is a little bit weird, right? That we have a material being imported by the static mesh importer, but that's just because of the weird nature of OBJ files and the way that they work with materials, right? So we also have another representation of materials, which is the primary asset, which for kohi is a KMT, right? So that's a kohi material, right? So this again has its own serializer. This one's not binary, but it's its own serializer, right? And then this then becomes a static mesh. I'm sorry, not a static mesh, a material, right? So if we draw the arrows here, the MTL goes through its own serializer. Let me space these out just a little bit more. Okay. So the MTL goes through its own serializer. The OBJ goes through its own serializer. Those both go into the static mesh importer, right? So again, I think I need to space this out a little bit more. I don't know why I'm making all this so close together. Okay. Let's actually grab these and move them over a little bit and down. Okay. So our static mesh importer will take in the output from the serializer, from both serializers. Let me fix my arrows here. Right? So both of these get fed in to the static mesh importer. And then the static mesh importer outputs a KSM file, right, which is our primary asset type, which then gets loaded in by the serializer, which then is loaded in as a static mesh, right, just as you would from the binary resource to begin with, and then the material half of that goes through, oops. Let me move this over here a little bit. I actually skipped a step. 1 second. The static mesh importer, goes through a little bit of a different process, right? So we have, it comes out of here, goes through the serializer, right, which serializes it then to a KSM, which can then be read back in by the serializer to deserialize it to a static mesh, right? So the importer for the static mesh here does the same thing. It feeds it to the serializer. Serializer is responsible basically for outputting the primary asset, right? Not directly, there is another layer in between this, but for simplification purposes, right? And then we can go from the primary asset to the serializer, and then from the serializer, we load a material. And I don't think I actually didn't put material here, right? So let me move this up a little bit, move this guy, right? And then we will just draw an arrow from here to the material, right? So this is more or less the way that this works, right? So we have all these different pieces that allow us to have a flexible system, right? And we could very easily have other types of importers, right? So this static mesh importer is really just specific to OBJ files, OBJ, right? We could have another static mesh importer that maybe imports, GLBs or something like that. And so we have these importers that are capable of essentially taking a source format, running it through its own little serializer to convert it to the data that we need, and then handing that data over to our actual serializer for the primary data type. And then that is output, and that's what we load here, right? So that's more or less the flow of what we're dealing with. I use this example because it's the most complicated. Most other examples are a pretty straightforward thing. So another example is a image asset, right? So an image asset has a couple of things. So it has a importer, right? So image importer. And this one, in our case, actually covers a few different formats. So like JPEG, PNG, etc., right? And that then also is responsible for loading from source assets. In this case, this particular importer does not have a serializer at this level, right? So we go straight from the source asset, which in our case might be, let's say a PNG or JPEG, etc., right? So in this case, we go straight from this to the importer, right? And then the importer will then take a copy of this guy. The importer will then output to a binary image serializer, right? And this binary image serializer will then output to our primary image asset type, which in this case is, what did we call it? I can't remember the extension for that for some reason. Did I write it in here? I thought I did. What extension did I go with? KBI, that's what it was. Kohi binary image. Okay, so this is KBI, right? And so when we come from our importer to our binary image serializer, we write that out to the primary file format. And then we also read that in through the same serializer, and then that serializer provides the final asset that will then be loaded in and used as the backing for the texture resource. Right? So this workflow here is the most common. And so we did this just to sort of split things up, but and we also did this to make our runtime a little bit more lean and have our runtime not be responsible for all of this. So before I touch on that, let me just check with chat and make sure that this makes sense to you guys. From Lake, how's it going? Good to see you. Singy, same thing to you. Got a question. I'm a 15-year-old going into high school for my first time. I was wondering how I would get into game dev school. Or if you're talking like a college or something, you would apply for it. I actually went for a degree in game art and design, and I can actually tell you I've not actually used it. So proceed with caution when it comes to that. I'm not saying don't do it, but do your research first. Make sure that it is something that you want to do. I would try learning how to do some of it on your own first. Generally speaking, you can learn a lot of what you need to learn on your own. If you do want to go to a program, I would recommend one of the better ones that are out there, like Full Sail or something like that. Look into that. But yeah, I would say proceed with caution in terms of getting into a game dev school. All right. Weird trash can with the 10-day streak. That's awesome. 10 streams. Yeah, that's awesome. I appreciate that. I was official. Good to see you. Super cool diagram, crystal clear architecture. Yeah, I think so. I mean, I've changed it slightly, but this is more what we're actually doing now. So speaking of that, if we were to sort of rearrange where all of this stuff lives, in terms of what library it's actually in, we would need to actually move some of this stuff around a little bit. So let's see, what's the best way to do this? So more or less, if we talk about, maybe I'll just create copies of these things instead of like moving them, because it is a little bit complicated. So what we can do, VBit, thank you for the follow. So what we can do is we'll talk a little bit about where all of this stuff lives in terms of libraries, and I'll just kind of make a new section over here off to the side, right? So here is, this is, let's see, kohi.core, right? And then we've got runtime. And then we have a new library in our project, which is kohi plugin.utils, right? So just a little bit of a refresher. So core is basically where a lot of our types live, a lot of our things like our parsers, some of our serializers, our containers, all of that kind of stuff. String processing, those kind of things. Super, super core stuff. And it's consumable in a library that can be used by not only the runtime, which is sort of what holds the game loop, what holds resource information, things like that. But it can also be referenced by external tooling, which is a big part of this, right? So we have core, we have the runtime, which, as I said, is basically what houses the game loop for the application. All of our systems, like our texture system, our audio system, our renderer front end, things like that. And then we have this new Kohi plugin utils, which is a bunch of stuff that is sort of optional, that we don't necessarily need in a runtime application all the time. So for example, I'm probably going to need to make these a little bit bigger. You know what? Maybe I'll just make these sort of generic. Let's take our assets, right? So our asset definitions, regardless of static mesh or any of that stuff, we're just going to say assets in general. Assets in general live in core. Okay. What we're going to say is our primary asset serializers. Our primary asset serializers also live in core, right? And that's so that we can access those from anywhere, whether it's the runtime or utils or whatever, right? Let's see. So our resources, I'm just going to make, I guess I could just put this here. So our resources actually live in runtime, right? Because these are things that are actually used by the application. So the best example of this is textures, right? Textures are actually something that's uploaded to the GPU versus an image, which is just an asset that sits on disk, right? So resources live in kohi runtime. Another thing that exists in the runtime is what we call our asset handlers, right? Let me space this down. There we go. So our asset handlers, they're not actually in this chart, but our asset handlers are what's responsible for checking and seeing if there is a primary asset, or if not, calling on an importer that's registered with it to go ahead and import that asset, tell the binary static mesh, or tell the primary serializer to write the thing out, to read the thing in, etc. It's sort of what manages this lifecycle of stuff right here, right? Whether it be the primary or importing from source. The asset handler is what manages that. So those live in runtime. And then our importers, as you might guess, our importers actually live in the plugin, the utils plugin, right? So the reason for that is because for something like an editor, we would want importers. For something like our testbed, we want importers, right? But for a game that we're going to ship, we don't need to ship the game with importers, right? We don't need the ability for the engine to have OBJ or MTL imports or raw image imports in our final product, right? And that is the primary reason we swap this out to utils. Our core doesn't need that and shouldn't have it. Our runtime doesn't need that and shouldn't have it, right? So the other thing that exists in here is our source asset serializers, right? Those are the serializers that are responsible for the source types of assets, right? So like these guys here. So those also live in plugin utils, okay? So we have serializers in two different places, but it does make sense, right? And I think that is most of it. There is one more bit, which is the asset system that lives in runtime, right? And that's a big boy, right? So the asset system is actually what, in fact, let's actually do this. Let's see, bring this forward. Where is that button? I know there's one here somewhere. I guess I'll just bring to the front. There we go. Right, so asset handlers are actually managed by the asset system. So let me actually space this up a little bit. All right. So just to make that clear, right? It's too big, I guess. I don't have to be perfect with this, but I might wind up using it in documentation, so try and get it close. All right, so our asset handlers are managed by the asset system. So anything from the runtime to our testbed application or any application can reach out to the asset system, say, hey, give me the asset system called this. and then it says, okay, well, what asset handlers do we have to process that? And then once we find the correct asset handler, it says, okay, does the primary asset exist? If it does, load it. If it doesn't, do we have an importer? If the importer is there, go ahead and load the source asset, right? And then import that and go through the life cycle. In the case of a release build, for example, our asset handler will not have any importers actually registered. So part of what this plugin does as it's initializing is it registers its importers with an importer registry. And so the reason for that is because if this plugin isn't loaded, we don't have the importers, which is done by design, right? Because we don't want importers for every single build. So for a debug build, we might include this, or for like an editor, we might include this. Or if you build editing tools into your debug build, but you don't build it into your release build, you would build with all three. Versus a release build, you would build with just these two. And you would get all of your normal loading from primary assets, but your secondary asset importers would not exist, right? So I hope that all makes sense. And there are references in code to primary versus source assets. And it's not something I went with initially in naming. I kind of discovered it as I was coding. So there are going to be some places where I actually need to update that verbiage, but that's the meat and potatoes of it, so to speak. So that's the overview of what we're doing overall. Let's see. Are there any diagrams, charts, drawings that can help us understand the organization, program, flow, data, flow, etc.? You already drew that, but can you put it in GitHub as part of the documentation? Yes, I'm going to. And that's part of the reason that I'm building things that look like this, right? Is because I am going to actually put this in documentation. This isn't right at the moment, 100%. So I have to fix this first and put it out there. And then this example will make it into the documentation as well. Very interesting. Been thinking about these things a lot. Happy to see you're working on this. It's calming my mind. Awesome. Yeah. This has been something that's been bugging me for a while because of the tutorial nature of the series. We kind of just made our asset loaders like very ad hoc, right? And our resources were actually loading assets from disk directly. And it just wasn't very organized or there was no separation of concerns, essentially. And in addition to that, since we've got a few more viewers here, I do want to point something out as well. So there is a poll going on in the Discord server that I would like as many of you to participate in, if you haven't already, as possible. So in the polls channel, which is over here on the left, this is just a screenshot of the Discord server. You can find that in the information for the stream or on the channel itself. But basically, we're starting to think about the first game, right? And I'd like to know what your guys' preference is on the first game, right? You obviously see my preference, right? But it looks like you guys are more leaning towards a small arcade-style game, but in 3D. We could say, screw it, start making the big game, or neither keeps adding stuff to the engine. So this is what this looks like right now. There are 2 weeks on this. So I'm trying to give lots of time for people to get in and vote. Spread the word. I'd like as many of you guys to get in there and vote on this as possible, so that we know kind of where we're going. I mean, I have seen these polls start off looking like this and then go a completely different direction. So there is also a thread. So if you want to discuss your idea, keep it brief, but there is a thread for that as well. But yeah, if you guys could go in there at some point and just vote, I'd greatly appreciate it. No, my preference is actually the big one. I want to make the big game, TM, right? That's why there's a check mark here, because that's the one I voted for. But it seems like most of the folks in Discord right now are leaning towards a small arcade style game. That's in 3D. We're not going to be doing a 2D game either way. Whatever we do is going to be 3D. So Please do explain why big. I don't know, just because I've been working on the engine for a long time and I want to work on a game. And I want to push it to its limits. And I have an idea of something I want to make that's a really big game that would take a while to develop and a lot of effort, but not any more effort than actually writing the freaking engine, you know? So, Dr. Elliott, good to see you. How's it going? I hope you're doing well. Oh, it looks like I missed an ad break. I will pause for the remaining minute. This timer is about 30 seconds off, so I will cut it off prematurely. Miles, thank you for the follow. Appreciate that. All right, another 15 seconds or so. All right, and that is where I'm going to cut the ads off. Miles, 90D, thank you so much for the Prime sub. I really appreciate that. The support means a lot. Thank you very much. I appreciate that a lot. It definitely helps. It helps cover expenses and stuff with running this project, right? So thank you. Greatly appreciate it. Okay, so we're done with this for now. Let's take a look at where we actually are with this. So I've gone ahead and done some updates in our big old to-do file for our asset type reworks, and I think I have most of the stuff checked off that we actually have done. So where we are is I essentially broke them out by asset type, right? So we have the asset handler and importer and OBJ serializer and the actual primary serializer for static meshes done. So this is a decent portion of the way done. There are a couple of small other items here that I want to do in addition to that, that are sort of, this one isn't even code, and then this one kind of isn't even code either. But, you know, they're just task items, so I don't forget to do them. Images are pretty much done. So image assets, we have the handler, we have the importer for common formats. The only thing that we really don't have done is extended formats, like KTX and PSD. So actually, I'm gonna mark this done, and then you know, we'll probably move these out to a future release because that's not really super important right now. So we have that done. I'm just going to skip past these. Materials is in progress, and it's mostly done. So we wanted to convert the KMT files from the sort of flat INI-like file format that they are now to KSON. That's actually done. We'll have to re-import all of them, but it's actually done. And then we want to have a special MTL importer. So right now, the MTL imports automatically with the OBJ file that it's associated with, but we want the ability to import just that by itself. So if you have one of those, but not maybe an OBJ file, you can import that. So that's a to-do on that. I also want to add like a default warning material that really stands out, that like glows and maybe flashes or something to use in place of a non-existent material. Right now we have the checkerboard, but I want to make it a little bit more flashy than that, right? But otherwise, we have the MTL serializer done, we have the asset handler done, we have the primary serializer done. Terrains, we renamed that to height map terrains because we are going to be supporting another type of terrain in the near future. So we've renamed the K terrain to a KSON-based KHT file for kohi height map terrain. We have the handler done, and we have the serializer for that. Scenes are actually in progress right now. I'm working on that as we speak. Audio and music may not happen right away, but in fact, I have this. This is wrong. That should be Cameo, right, for Kohi Music, and then audio effects will be KFX. So we'll need to write those. We do also have ones that aren't actually listed here, so I should add those as well. We also have a handler, serializer, and I think that's it. Yeah, a handler and a serializer for just regular binary files. Like if we wanted to load an entire file as a binary blob, we have something for that. We have one for regular text files, and we also have one for KSON files that automatically build a KSON tree on import. So I'll need to add those to this list as well. So we're pretty far along, and a lot of these will actually build based off of what we already have. So, but like I said, right now, scenes are what we're working on right now. So specifically, we're working on the serializer. That's what I've been working on off camera. And then we'll do the asset handler. Scenes do not have an import process, so there's not going to be any importer or anything for that. So we'll do scenes, and then we'll do probably bitmap fonts, and then system fonts, and then shaders, which, we have some items in here about the hot reloading and stuff we'll have to fix too. And then once that's done, we'll try and knock off some of the little to-do items in between. But that's kind of where we are with this so far. And then we're going to have to rework the resource half of this as well, so that all of our resources now use these new assets and know to wait on them and so forth. So that'll be the other half of this. And then once we have everything working, and we know that things run, right now it's actually going to wind up loading really, really slow because we're not multi-threading anything right now. So all of this new asset system stuff is all on the main thread, which is obviously not ideal, but we want to get it working, and then we're going to jobify all this stuff so that each one of these steps can actually be doled out to an individual job, and we can make full use of all the threads that we have available. So, all right, let's see. What was your idea for the arcade one? I have a couple ideas. Yeah, it's just like a small game that you can kind of pick up and play casually, right? Something like maybe a simple platformer or like a bullet hell game or something like that, And the big one, FPS MMO, GTA 6. I can tell you it's not an MMO. That's all I'll say right now, but it's not an MMO. Demo game that has huge terrain, show how to do dynamic loading, unloading of meshes, terrain, etc. So you're talking about asset streaming, which is another reason I'm doing this. Because asset streaming will be a lot easier to implement using this. Are you dynamically creating shaders based on the material? Not yet. Not yet. So we do have something that's referenced a few times in code, and it's not actually filled out yet, but we do have something called custom shaders, which is going to hook up to a shader graph where we will be doing that. But we're not doing it yet. So right now we basically have one lighting model, which is PBR. But we are going to have other shader types. We took out Fong a while ago, but I'm probably going to wind up putting it back in. So we'll have a few standard types of shaders that come with the engine that you can just say, okay, well, I'm going to set this up as a PBR material, and here's all the things I need to fill out for that. And then we'll have a custom shader that you can then go in and set all that stuff up yourself. You can load your own custom shader file, or you can try and build one in a shader graph, and it'll build the shader file for you. So there's a few things that I want to do with that experimentally, but we're not there yet. Okay, so I think we're finally done talking about where we are. So let's get on with it, shall we? Okay, so all of these serializers look kind of like this, right? So we have the K-asset scene serializer. That's the one we're working on right now. So here is in core our serializers that we have written so far. So we have a binary image serializer, a binary static mesh serializer, a height map terrain serializer, one for KSON, one for materials, one for scene. And then we have our importer registry that I talked about. And then if we look down here in our plugin utils, we have our importers, right? So one for image, one for static meshes, and our serializers. Right now, just one for OBJ material serializer and OBJ serializer, right? So we have those there as well. So that is that. So most of what we're going to be doing from here on out is going to be in the core, in writing these serializers, and then making asset handlers, which are all in runtime. All right, so those are under source, assets, handlers, and here's all of our. Let me clear highlights. Here's all of our asset handlers that we have so far, right? So we have one for just straight up binary files, height maps, images, KSON files, material, static mesh, text. So the next one of these we're going to write is a scene, one for the scene. Okay, so the way that this guy is set up is we have a serialize function that takes in a K asset. It's just a generic asset, right? And the reason for this is because we have we use function pointers for these, right? So they all have to have the same signature. So we take in the generic asset, and then we can cast it to our typed asset. So in this case, it's a K asset scene. And if we peek definition on that, the reason that cast works is because the very first member is a K asset, which is base, right? So if we, again, peek definition on this, our base asset is here, right? So this is the generic sort of high-level thing, the information that every asset has. So a unique identifier, a generation, which will eventually include increase every time it loads. We're not doing that right now, but we will. The type, which the type is here, right? So we have all of our asset types that are well known at the moment. You'll see some ones in here we don't have yet, like voxel terrain and skeletal meshes, right? So we have some plans for some stuff. And then we have some metadata. So the metadata has the asset version, right? So asset formats have different versions, right? So some of those are on version 2 or 3 already. And then we have the size of the assets, which this may or may not wind up being unused. I may wind up getting rid of that. We also have something called a K-asset name, right? So we'll get into that in a moment. We have the K-asset type here, right? So that's the, obviously the type. Actually, wait a minute. Did I include the type both? Oh, I included it both in the base and the metadata. That's dumb. Okay. So the only other thing that's in the metadata then is the source file path. So whenever we import an asset, we should be filling that out. I don't think we're doing that all the time, but yeah, we probably should be. We could also extend this later on to allow like asset type specific metadata, but we don't have that yet. So I just left that there as a to-do. So there's the metadata. The name, oops, I gotta go back into that. So the name is basically this, right? Where is it? Up here. So we have the fully qualified name, which is the package name dot asset type dot asset name. And then we have the 3 parts of that, right? So basically when we create a name, we parse this string once and then split it into the appropriate parts, and we don't have to parse it again. So that's what that is. And now we are back to our scene, right? So we have all that base information there, and then we have a description, which if we take a look at a scene file, a scene file right now has a description, right? And it has a name, which actually isn't being used, so we're getting rid of that. And both of those are in a properties object within the KSIN file, right? So that's sort of our top level type of stuff. So we have a description, then a node count and nodes. So the node count and nodes represents this array here, which goes all the way to the bottom of the file for all of our nodes that we have in the scene. And then the scene node contains sort of the flat version of this, right? Or not flattened, but I guess, you know, the basic copy of this data that's deserialized from the text file. So each individual node has a name, an attachment count, an array of attachments, a child count, and an array of children, right? Because they can be nested. And it can also optionally have an X form. So we store that in string format here because our scene is actually responsible for turning that into a proper X form. So not every node is actually responsible or has to have an X form. A great example of this is like environment nodes like this that don't really need a transform. A skybox doesn't need a transform, a directional light doesn't need a transform, so why give them one? So that is optional, right? So the attachments are things like your skybox attachment or a directional light or a static mesh or let's see, or a terrain or water plane, right? And so those each get deserialized and serialized based on their type. And so that is, we basically build up this structure, or a tree, if you will, almost, with all of our scene data in it, and then we feed that over to the actual scene resource, and it can take this and trigger the loading of all the resources and assets that we need. So, that being said, here's our serialization for it, right? So we take in in this case, it's a text serializer. So we take in an asset and return a string. That string is this file, essentially, right? So we have a serialize, and then we have a deserialize, where we take in a string, presumably from a file, and we output the asset to this pointer, right? This out asset pointer. And then we indicate whether or not the operation was successful, right? And then we have a couple of functions. So we have one for serializing a node, which can be called recursively because nodes can have children nodes, and then one for serializing an attachment. And this goes into parsing each one of these attachment types. And then we have the deserialize node, which also works recursively, and the deserialize attachment, right? So we have those, and they are called from the appropriate place in code. So I'm sure you can probably guess how this works from a high level. If not, the code will be available on GitHub so you guys can take a look through it. I promise if you read through it, it does make sense. And so where we were was I basically got everything in here done except the very last portion of this, which is the deserialize attachment. So deserialization is basically going to say, okay, we have this KSIN object that contains all the data that we need for this attachment. Let's pull out the fields of that based on what the attachment type is. And from there, we will be able to create an attachment and place all of its information into this pointer. Can you share the planning app? I was on mobile and couldn't make out the website. Yes. It is called Excalidraw. I will drop a link here. I'm not like sponsored or anything. It's free. They do have a paid version, but yeah. It's a pretty good little piece of software, and you can actually export images from it too, which is nice. Okay. Nivimi, how's it going? Good to see you. Got my vote for the big 3D choice. Nice. All right. So what we're going to do here is we're deserializing this. So we're essentially going to need to undo the operation that is done by the serialize attachment. So I'm actually going to go here, and I'm going to I'm going to copy pasta this. The reason being is because a lot of this code is going to be similar. We just have to change it from serialization to deserialization. So it's actually, I found that the deserialization is a little bit simpler. Okay. All right, so we have attachment name is the first thing. Let me get rid of this. So the first thing we do is for the attachment name, we say, hey, does the attachment have a name? Because the name is not required. If it doesn't, let's just use unnamed attachment. And I suppose we could, not do that, just leave it blank. We may come back and change that, but for right now, it just makes it a little bit easier for us to call it this. Also, for error reporting, we use the attachment name, right? So, in fact, right now we say if the name exists, then we're going to go ahead and write it out. Now, this is our serialization code, so we need to do the opposite of this. So what we need to do is say get the name if it exists, right? So at this point, our attachment name is not going to be known here. We're going to have to move that down until after we actually parse that. And then what we can do is we can remove that, and instead of a add string, we're going to do a get string. And in this case, since name is not required, we're not going to do this if check, right? If we get it, we get it. If we don't, we don't. Okay, so let's just do that. Okay, so we're going to get the string, which means we need the object, which is the attachment object. That's the case-in object. We're going to look for a property called name, which I don't know if any of these attachments actually have names. I think the terrain one, I think I put it down here. Yeah. So this attachment has a name, right? For example. And then we're going to output that to attachment name, right? And then we can do attachment name here. If it exists, we use it. If we don't use it, then we use unnamed attachment. And this is really just for error reporting, okay? So in this case, it's optional. So we're not going to throw an error in this case. What isn't optional is the type, because how are we going to know what to parse if we don't know the type? So the type absolutely is required, okay? So what we need to do is we're probably going to have to write a little bit of, we're not going to be able to use a switch case for this, right? So this is going to get a little bit different here. So instead of add the type, we want to parse the type. So here, again, we're going to do get string, and then type string. We actually want to output to type string, right? So let's set that to 0 and then do the address of type string, right? We want to extract that out of here, right? So that's going to be like this, for example, which this is actually going to be wrong, and we're going to handle that as well. So if we do not have that, then failed to parse, I'll say required type property for attachment, and then we'll use attachment name, right? So if type isn't there, we're kind of screwed, right? We can't do anything else with it. We return false and say that the deserialization of this attachment failed. So the next thing that we're going to need to do is we're going to need to check the type. And this isn't going to be as easy as a case statement here, right? Because we're dealing with a string, right? We don't have this type here. So I suppose what we could do is we could probably just write we could write a little bit of code here to sort of quickly convert that. So we do have this lookup table, which is in K-asset types, I believe. Let's see, did we put it here? Yes. So we have these attachment types here. There's our enumeration for that. And then here are the string representations of those. So the way that this works is whenever we add an asset type, or an attachment type rather, we'll need to also add it to this array, because we have a static assertion here that says, hey, if the length of these ever differ, we're going to not allow you to compile, right? So instead of having to do a whole bunch of string comparisons and things like that, this aligns to this down here, right? So we can literally just take the type, index into this, and we'll have the string we need. So what we can do here is do, I guess, we're still going to have to do a type comparison, right? So I guess what we'll have to do is, I guess we could just for loop it, right? We're only going to really be doing this on deserializing an attachment. Which actually is going to happen a lot. There's not really a better way to do it though, because it is a string we're dealing with. So I guess we can loop through those, although there is another wrinkle thrown into this. So what we're looking at here is a version 1 file, right? Is what we're calling version 1.
Thank you for all you share.
VSM, thank you so much for the Prime. I appreciate that. Thank you very much for the support. 2 months. Appreciate that. Thank you very much. So what we're looking at here is version 1 of this format. And the reason that I'm deciding to branch off and create a version 2 of this is because I want to test the versioning stuff. So version 1 format has this properties object up here and contains name and description. Version 2 just has that, right? But also has an actual version declaration, right? So version 1 does not have that, but does have the properties, and version 2 has what I just showed there, right? The other thing that's different is we had named the terrain attachment just terrain, right? Where now this should technically be height map terrain, right? Because we're going to have multiple types of terrains. But for backward compatibility, if somebody writes terrain in here and they have a version 1 file, I want to support that, right? Now, obviously, I don't need to do this. You know, I could very easily just say, well, we're just not going to support, you know, old versions of the software, right? And that would be a perfectly acceptable thing to do. But you know, to test out the versioning of this, I've already written some code in here to handle this portion of it. So what I'm going to do is we're going to do that, right? So what I'm going to say here is some things in version 1 were named differently. Try those as well if v1. Okay, so we can actually look at the asset, which in this case will be, oh, we don't have that yet, do we? We actually need the asset, which we don't have here. So I'm gonna have to change this function a little bit. Let's do k-assets, taking a pointer to that. And we'll do this here, which actually means that we're going to have to do it here because deserialized node calls deserialize attachment. So let's get it. Oops, let's get it here. And then we'll pass in asset there. And once more here. And we have ads. Hello, can you do ethical hacking? No, I'm not. I'm not a I'm not a hacker by trade. Unless you're talking about, hacking like what we're doing here, which is sort of the old definition of hacking, is just, writing stuff. Or writing hacks, hacked code. But not like network hacking in the sense that everybody talks about it these days. No. We're only unethical around here. This is a pirate crew. I mean, we do, take care to, be as family friendly as possible and bleep out terms like VS. So, we try to be at least somewhat ethical. How are you doing, Sergeant Pepper? It's good to see you. All right. Just about done with ads. Doing all right? Good. Awesome. Glad to hear it. Okay. So, in this case, if asset meta version equals 1, then we can try the fallback types. To do fallback types. Okay. So what we're going to do here is we're first going to loop through the v2 types that we know about, and we're going to try those first. And then if we happen to be v1, then we'll fall back and try that as well. I suppose what we could do is we could work this into the loop itself. So I guess we could say, let's say for u32, I equals 0, I is less than, attachment type count. There we go. And then plus I. And I suppose we could do this, right? And then say, we'll do a if strings equal I. And we'll do KSSC nodes attachment type strings sub I, right? Because that's going to be the type. So we'll compare that to the type string. And if that passes the test, then we have our type, right? So we'll say kasset type. We'll just put type up here, right? So we can say type equals I, break, and we're done. Okay? Now, if for some reason we do not, well, if we don't match this, then we can check our fallback types, right? So in this case, we can say if I equals kasset scene node attachment type, and then we want static height map terrain. That's named wrong. I need to fix that. That seems like a rename failure there. That should be height map terrain. Right, so let's just get rid of that. Okay, so if we're checking terrain, then we can also say if strings equal I. And this time we're going to check against just terrain, right? Against type string. And if that's the case, then we'll say type equals I and break. Right? So that's how we're going to handle the fallback names. I think, did we, was this always called static mesh or was it just called mesh? That's the only other one I can't think of. I think it's always been static mesh within the scene file. You know what, let's look in the old serialization routine. Not that many matches in here. Let's see. Yes, okay. So it was static mesh. Okay. So we don't need to worry about that. Okay. So let's do find the attachment type. Okay. And then this is how we'll sort of handle like legacy versions, right? Okay, cool. So what that's going to give us is we'll now have the type converted to the actual type, which we can then use a switch for, right? And so basically what we have to do is for each one of these types, we have to do the opposite of what we're doing here, because this is copied from the deserializer. I'm sorry, this is copied from the serializer, and we're writing the deserializer now. Okay, so in this case, I guess the first one we're tackling is Skybox, right? Which the only thing besides the type that's required. Oh, you know what? We don't have a failure case here. Let's do B8 type found equals false. And we'll do type found equals true here and here. And then here we'll do if not type found, and then we'll bleat about it. So unrecognized attachment type. We'll spit out the name that was provided. Attachment serialization failed. And then that's going to be type string. Return false. Right? So let's make sure to cover that failure case in case they enter some gobbledygook in there that doesn't make any sense. Okay, so for each of these, we're gonna parse out the properties, right? So the first one's Skybox, so all that really has is cube map name. So what we want is we can actually completely remove this. So we'll say we'll start that off at 0, right? And we're gonna say get string. And we want to get, cube map image asset name. Right. Okay. So we used to call it cube map name, which is a little bit non-descriptive as to what it actually is. We renamed that to cube map image asset name. So this is another one of those rename cases that we'll need to handle. So in this case, we look for one that's called cube map image asset name. And then we output it to cube map name. If we don't find that, then we're going to take this and we're going to try one more time. This time we're just going to go by cube map name, but only if asset meta version equals 1, right? So we're only going to do that in that case. Right, and then we'll put this here, and then handle our error here. Thank you for the follow, appreciate that. Wow, I found a real programmer. I don't know about that. We do dingus-oriented programming here. I screw up with code all the time on string. So, we'll see. We'll see. Okay, so if we're on asset version 1, then we will try falling back to this name. If that also doesn't exist, then I guess, well, let's do this, right? Let me think how I want to do this. Okay, if it succeeds, then we're not going to want to do this. Unless we're not on asset version 1. Oh, did I move those too far? Yes, I did. Okay. So in this case, let's modify the error message because we're parsing the backup name, right? So if we don't find that, we error. If we do find it, then let's see, how do we, I guess I could just do this. I'm not usually a fan of putting else's all over the place, but it'd be great if I could quit hitting the wrong key. There we go. Okay. So if we do pass this test and we pass this test, we pass one of the tests, in other words, then we have the cube map name. I guess instead of outputting it here, we should just output it straight to the attachment, which is going to be, we want, do we have the typed attachment? Typed attachment. Cube map image asset name, right? And we're going to do the same thing here, right? So we'll output that directly to the name, and then we're good. Okay. So that's how we'll handle the versioning on that. I guess I could put a comment here. Try fallback name if v1. And again, I don't have to do this, right? It's just a proof of concept on how we're going to handle the versioning, right? So it is eventually going to be relevant once we have releases of the engine, right? We are going to want to be backward compatible to an extent, at least within a version. Your scene data looks like Valve's VDF format. I'm not familiar with that format off the top of my head, actually. Let's see. See if I can find a non-crappy spec. Oh, that is pretty funny. It does look a lot like it. Yeah, you're not wrong. This bit's a little bit different. Yeah, but it's got the nestability and all that stuff. It looks like they treat everything as strings, though. Interesting. Okay, so what this actually is over here, in case you didn't catch it before, by the way, this is actually what we call KSON, which is it's similar to JSON, but it's our own format that we wrote because this is an educational series and we wanted to cover writing a storage format. So it's what did we say it was? Kohi object storage notation. So it's kind of we have our own parser that goes with this. We wrote our own lexer parser, tokenizer, all that stuff. And, we use this now for our data files. So we used to have like an INI kind of file format that we used for everything, but that wasn't expressive enough and didn't allow me to nest stuff. So we wrote this, and it's actually been incredibly useful to have that. So thank you for the follow. Appreciate that. Smudge, how's it going? It's been a bit. Good to see you. Appreciate you stopping in. Long time no see. We are in the middle of writing a new deserializer for our scene, and splitting that out from the scene resource among all of our other assets and resources. Okay, so that's the skybox. Directional light is next. So, I should point out, I added a few new things to our KSIN parser to allow us to grab some of these vector types, because in this file format, these types are stored as strings, right? So let me see if I can find an example. Here we go. So like this is a vector 4, right? But the way that we do this is we store it as a string. That way we don't have issues when we're tokenizing it. And we then take that string and parse that string out to a vector 4. And we can reverse that operation as well. We already had the utility functions in our math library to do this. So all I did was basically just leverage those and then hooked up convenience functions to essentially read out a temporary string internally and then do the conversion one way or the other to and from vector 4 and then add it as a KSIN object. So need to move to Twitch because YouTube is lagging a lot. Yeah, that's fair. I've noticed that YouTube doesn't seem quite as good on streaming in terms of lag and stuff for some reason. It varies. Okay, so what we're doing here, we have our typed attachment, right? So that's just a cold cast. And then instead of add a vector 4, we need to get a vector 4. Thank you for the follow. I appreciate that. So let's see. Hi, Nivy Welcome to the Twitch side. Okay, so get vec4. Wait a minute, do I not? Oh, vec4. Helps to spell it right, you dingus. Okay, so we're going to get color, and it's going to output to typed attachment color. Right, so all we're doing is just a get for that. And then we'll say, whoops, get. Okay. So that's essentially all that we're doing. Whoops, that's not even the right one. This one. Right, so these are all gets now. Let's just change these. And we're going to do direction next. So we'll just do get vec4. Right, and we just take the address of. So it's just a minor change in direction, right? So get float. And again, take the address instead of a copy. So I guess I can actually just okay. And then we just need that. Okay. So we just get all of those. And that's all there is to the directional light, thankfully. It's pretty simple. Point light is actually going to be pretty much the same thing. So in this case, we just want to do get vec4. And again, take the address of that. All right. So there we go with that. That's position. Next will be the linear, constant, and quadratics. So I'll just change those and then get floats. All right, so I want to do that and that. Okay, let's see, we also need to say get. Okay. So those are just simple extractions of those properties, which is a lot cleaner now than it used to be. Because you used to have to read in a string from the property and then call the parse function manually, which is not great. It's purple. Finally, don't need to refresh the page to continue watching after 5 minutes. Oof, that must have been annoying. All right. So static mesh, I believe, is actually just a name. Yeah, it's a resource name. So, we have a bug here that is going to be present in our serializer too. How did I miss that? That should be asset name, which also means, let's see, attachment serialize. That was for the static mesh. No, that's not here. Okay. I must have fixed it already. Oh wait, I went into deserialize, didn't I? Serialize attachments is what I want to look at. Yeah, there it is right there. That should just be asset name. We also have this. That's wrong. We renamed that. So let me just fix that. Let's see. What did we do here? Deserialize node. Oh, this should be node object. Ah, there we go. Okay. And then this one is also wrong because we renamed that. All right. So deserialize attachment, we have the asset name here. This was previously called resource name, so we are going to have to be backwards compatible with that. Which is fine. I think that's the only other thing. Terrain's going to have that issue too. Okay, not a big deal. All right, so what we'll do is we're not going to do this portion, right? We want to do get string. We're going to say asset name, and then this is going to be typed attachment asset name, and we want the address of that, right? Failed to get. Okay, but since this is also, we want to maintain backward compatibility. If that fails, then we're going to take a copy of this and instead of asset name, we're going to say resource name. But we're only going to do that if the asset meta version equals 1. Okay, so in this case, we want to move this here and put this in an else block. Right? And then if this fails, we're actually going to use a very similar error message. Except in this case, we're going to say resource name, and this should just be asset name. Okay. Try fallback. Okay. So if we happen to be on version 1, we didn't find asset name, we're going to try to load resource name. If that's not found, then we error. If we're not on version 1, then it's an error. Otherwise, we're good. Okay, so static mesh is that way. Height map terrain is also that way. And in fact, the logic is exactly the same. So what I'm going to do is literally copy pasta. Yeah, okay, cool, done. All right, now the last case is that says static water plane. That's wrong. That should just be water plane. Let's fix that too. Fix it in this comment here as well. Okay. So our water plane, if we recall, does not actually have, oh, I think that's all the way at the bottom actually, and I'm gonna have to drag this over here so you guys can see it. Okay. So we have, actually I could just scroll up, that's fine. So we have our test water, which has an X form, right? Attachments type water plane. Now we do have this reserved here. I'm not going to bother keeping that. We don't need it, right? So let's actually just get rid of it, right? We weren't parsing it anyways. So eventually we'll have things like wave speed and stuff be configurable on this, but for right now we don't have any properties. So I've made a note here that the section is deliberately blank until we actually sort that out. And then obviously, if you are trying to pass in as the asset type the type count, which is the last entry on this enumeration, so that we know how many of these we have, if you try to pass that as the type, it's going to yell at you and call you a dingus. So don't do that. Okay. So we have one error in here. What's the error? Ah, we're not passing through asset. Wait a minute. Scene serializer. Serialize. Oh, it should be out asset. My bad. Okay. I think all errors and warnings are done. Let's see if this builds. And then we'll move on to the next step. Let's see. Node is uninitialized when within its own used. Whoa, what did we do there? Okay, line 440. No, oh. C node. But then node is, Oh, node is passed in here. Okay. So this is just a crappy name for it. So this should be, instead of node, it should be child. And then deserialized node should be child, because it's a child node. I wonder if that same mistake exists in serialized node. Oh. Nope. Okay, we got it right up here. Then we passed it. Okay, all right, so we should be good on that. One more thing. Variable type set but not used. Oh, I think I know exactly what that one is. 473. Because we parsed the type, but we never actually changed the switch statement to use it. We're still using the attachment type, which is not even set yet. Oh wait, why did I put... That's not asset type. That should be... K-assets, C node attachment type. Which actually... Oh, you know what? This should be attachment type, because we shouldn't be doing this. We should be setting attachment type. There. That makes more sense. Do you have Wayland support because the engine crashes right after rendering a few frames in Hyperland? That's weird because I started the development of this in Hyperland. We don't have native Wayland support yet. We use X Wayland for that. We rely on that. I do need to write a Wayland layer. I just haven't had the time to do it, frankly. And I also have to research how Wayland works because I don't know under the hood. I've only ever done this for X11. I've not actually written a backend for Wayland yet. So that's going to be quite time consuming when I get to it. I'll tell you what though, what distro are you on? If you want to send me like a stack trace and Discord and a little bit of information about like what the logs say, if anything, and that kind of thing, I can look into it. Because I've tested it on Ubuntu and Arch. Oh, you're on Arch. Are you on NVIDIA by any chance? Or are you using AMD? Because that's the only thing. You're on AMD. Okay. So I do have an AMD machine that I built here, but I haven't installed Linux on it yet. I still have to. I need to put a Linux install on that so I can actually test that. So I might find it that way, but if you wouldn't mind, if you could go either on the Discord server or frankly just write up a bug if you have like a stack trace and a log file and that kind of stuff, that would be super helpful. And then I can look into it. Memphis, how's it going? Good to see you. All right, so barring any bugs, I think our asset scene serializer is done. So let me just make sure that I did the header file correctly. Yep, that looks good. Okay, so we now have for the scene, where is it? We now have the serializer written. And which is good because the asset handler requires the serializer. So the cool thing about the asset handler in the way that we've set those up is we can go to, let's take a look at, you know what, let me close this. Let me go to, which one do I want? Which one would be a good example? I guess we could use height map terrain because it's a KSIN file as well. We could use this one as an example. So this is all there is to the actual asset handler because we were able to abstract a lot of stuff off to a sort of asset handler base function. So the way that this works is an asset handler has a create function where it stands sort of itself up with any information it needs. So it sets the request and release asset function pointers, which are here and here, respectively. It sets the type of asset it works with here. It sets the type name of the asset it works with here. And then if it has a binary serializer, it sets the function pointer for serialize and deserialize. If it has a text serializer, it sets those. You can have one or the other. You can have neither. You can have both. All of them have a little bit different requirements, right? So you basically configure what the handler needs to do here. And then this function, which is request asset, is almost identical for every single loader, or handler rather. So we grab the virtual file system states. We set up some context to say, hey, here's the listener, which is the listener instance, which is passed in from the requester, the asset handler itself, the asset that we're trying to load, so pointer to hold that, and then the user callback that should be called passing along the listener instance whenever the asset is loaded. And then we just call off to VFS request asset. And so we pass a whole bunch of stuff like the asset metadata, the VFS states, whether it's binary, whether or not we're loading a source asset or not. And then we then have a like a size of the context that we're passing along, which is this, right? And then the context itself. This takes a copy of that as soon as it gets into the function, so we don't need to worry about lifecycle. And then we pass along a callback to tell the VFS, hey, when you've loaded this thing, this is what you go and do next. So it calls this essentially, which is a base handler for all asset types. And we can provide a different one as if needed, but I figured out along the way as I was doing this that a generic one covers like 99% of cases. So almost all of these wind up looking exactly the same. You might have to tweak a property or two in here, and that's about it. And then release asset is responsible for the asset specific releasing of stuff, right? So what this is in our KAsset utils, we have a whole bunch of functions in here that does all kinds of different stuff. This is sort of the logic or generic version of the logic we wrote on a previous stream, where it tries to load the binary asset first, which is where this is called from, right? And then if the binary load fails, we check to see if there's a source path for the asset. If not, this whole thing fails. If the source path exists, check to see if there's an importer for that asset and source file type. If not, it fails. If an importer exists, run it. If it fails, this fails. And then this says, on success, attempt to load the library asset again. We're not actually doing this step because I found it to be unnecessary. Our serializers actually give everything over to the asset as needed, so we don't actually have to write it to disk and then reload it from disk. We could for verification purposes, but there's not really a need. Okay. So I did see that there was, I heard like a ding, but I'm not sure what that was all about. So if somebody followed, thank you. I missed the notification, and I guess. Psycode, how's it going? Good to see you. All right, so basically, this whole block of code does exactly what this says up here, right? So if our asset load was a success, then it goes ahead and tries to determine what to do from there. So if we are loading from a source file, then that means we need to run an importer against that, right? So if it's from source, we'll say source asset loaded, and then we go ahead and grab the extension from the file and then say what importer, if any, is capable of handling this. If we don't find one, we say, hey, we don't have a handler for this, and we're done. If we do find one, an importer, but that fails for some reason, then we say the auto import failed, right? If we have a binary serializer, it runs the data that was loaded from the VFS through that binary serializer. Otherwise, if we have a text serializer, it runs the data through that. I can't think of any situation where these might need to be reversed, so we may actually have to revisit this at some point, but for right now it works just fine. And then we go ahead and, of course, do any cleanup that we need to do. So if we're not loading from source, then we say, okay, primary asset loaded. And again, if we have a binary serializer, we binary deserialize using that by calling this, right? And if it's success, then it's a success. Otherwise, it's a parse failed is what we consider it. Otherwise, use a text deserializer if we have one, right? And if it falls through and doesn't actually hit any other error condition, it defaults to internal failure, right? So the only way that you can hit a success is if you actually go through a serializer and have it return a positive result. So once that's done, at that point, you make the user callback, passing through the result, the asset, and the listener instance. And it's up to the system or whatever initially requested the asset at that point to go ahead and process the asset. So the nice thing about splitting it up this way is all of this stuff can be jobified, right? This whole section right here, we can jobify all of this and actually set it up on a separate thread. And so that will definitely speed things up and also help us when it comes to things like streaming assets. Binary and text at the same time is usually not a thing, so that order should be fine. Yeah, exactly. It should be fine. I can't think of any situation where it wouldn't be. There are... Which one was it? I think it was the... One of the asset handlers had both. I think it was material? No. Maybe it was static mesh. Yeah, it was... Nope, it wasn't either. Did I factor that out? I guess none of them have both. I thought there was one that had both. Apparently not. All right. Well, yeah, okay. There's this one that has none. Anyway, I guess that's why it hasn't been an issue yet. Regardless, that's the way our handlers work, right? So what I'm going to do to create our handler for our scene is I'm going to pick one that's very similar to it, which is actually the height map terrain one. So I'm actually just going to, you know what, instead of doing it this way, I'm just going to copy the file. And we're going to name it asset handler scene. And we'll take the C file and we'll name it scene. All right, and then we'll just do a find and replace. So we'll do height map terrain, replace it with scene globally. All right, and then we'll do the C file. We'll do the same exact command there. All right. And there's just a few things that obviously got screwed up from the find and replace. It's not case sensitive, doesn't maintain the case. So we just got to fix a couple of those. Okay, so this should be scene deserialize, right? We're using our scene serializer here. Okay, so that's that. Request asset, that should be good. And then the only thing we have to do is free up our specific asset data. So the only thing that I can think of, we'll need to free up all of our arrays and our properties, right? So if we have description, for example. So we need to free description. And then we're not dealing with materials here. We're dealing with nodes. So node count, right? Nodes. Node count. Nodes. And then this is going to be material not material, scene node. All right, and obviously this is not named material name. That's kind of ridiculous, right? So let's call this node. What is this bleating about? Do we not have... We have k-asset types in here, I think. Don't we? No, maybe we don't. Well, I think asset handler types does. Yeah, it does. All right. So what is this complaining about? Oh, because I didn't take the address. Derp. Okay. So let's get rid of that. We don't need that. And then so what we're going to have to do is recursively destroy nodes, right? Because nodes can be nested. So we are going to have a little bit of work to do on this one, but it's not too big of a deal. We'll do void, static void, and we'll do destroy node. Okay, and this is going to take a k-asset scene node to destroy. Right, so here we can do destroy node, right? And actually, I don't even need to do this. Thank you for the follow. Welcome. Let's actually just do... Oh, did I just seriously wipe my... I wiped my clipboard. There we go. Okay. So we destroy all the nodes, and then we free nodes, rather. And that's going to be the size of k-asset scene node times node count. And then node count nodes. Right, so we destroy all that, and then in the actual node itself, we'll destroy all of that. Is this project on GitHub? Yes, it is. So actually right there, there's a link that just got dropped automatically by my bot. If you go to kohiengine.com, it'll take you to here. And you can find links to YouTube, Twitch, all that stuff, but you can also find on GitHub. So it's all here. It's open source. It's free and open source. It's Apache 2.0 license, which means if you want to use it personally or commercially, it doesn't matter. All I ask is that you just say that you used it, right? There will never be any sort of licensing fees or royalties of any kind. It's always going to be open source and free. So. I think your build scripts for Linux are outdated. They shouldn't be, because I use them on the daily. I know I'm on Windows now, but I use Linux all the time. Like, the only reason I'm on Windows now is because I happen to be booted into it for something prior to the stream. What about it is updated, do you think? Because if that's the case, it's probably not good. Let's see. As a general rule of writing C, if you see an error, you probably forgot a ampersand or a asterisk somewhere. Yep, exactly. That's why I usually look at the types and I'm like, wait, okay, the base type is correct. It's actually just missing the address of operator. Okay, so destroying a node. So the first thing we're going to do is this is going to recurse, right? So the first thing that we're going to have to do is for u32i equals 0, I is less than node child count plus I. Okay. And for each one of those, we are going to say destroy node. And we're going to say the address of node children sub I. And then at the bottom, we're going to say, actually, it's going to be the same pretty much as this. Right? So we're going to say node children, size of a node, right, times node child count, right? And then we'll say node children equals 0. I guess we don't really need to do this, but just to be on the safe side, we'll do it, right? Okay, so that's destruction of the child nodes. Now we need to handle the attachments, which are specific to, obviously, the type of attachments. So the first thing that we should probably check for is if node name, right? We need to free the name. So we'll say string free node name equals 0. Okay, so we'll get rid of that first, and then we'll do attachments. And for that, we'll just set up another for loop. So u32i equals 0, I is less than node attachment count plus I. And I guess we could have like a destroy attachment. I think I'm just going to do it in line. I don't see why we need to do anything other than that. So what we'll do is we'll say k assets seam node attachment. That's going to be attachment is equal to the address of node attachments sub I. All right, and we'll say if attachment. Actually, no, we'll do a switch attachment type. Right, and then this is bleating about enumeration values not handled, so populate. So we'll handle each one of these one at a time. So we'll do, I like to do a cast individually, And I like to do that within these so we have proper scoping. So we'll say K assets, scene, node, attachment, skybox. Right, and we'll do typed attachment. And that's going to just be the same thing again, which I'm not going to type all that out. Right, cast it to a pointer, we'll say attachment. Okay. So now we'll say if typed attachment, cube map image asset name, then string free, typed attachment, cube map image asset name, typed attachment, cube map image asset name equals 0. Right, so we're just going to free all of this stuff. Rukuwu, thank you for the follow. It's a funny name, by the way. Anything with uwu in it always makes me laugh. All right. So let's paste this. Let's see. What else is likely going to have a similar structure? Probably static mesh and height map terrain. Let's see. Just throws a lot of errors. When I try to fix them, they throw more errors. Have you installed dependencies? There are a couple of libx11 package that are required. Yeah, that could be. After a few months, problems are gone. But there's more with attempting to free already free block of memory offset and sigtrap. Ooh. Okay, so I wonder... I have found a couple of... what did I do here? I have found a couple of issues around that I have actually fixed in this latest branch. Are you pulling from the main branch by chance? Are you trying to work off the main branch, or are you working off this feature K-package branch? Or better yet, the 8.0 branch? You're from main? Okay. The first thing I would tell you to try, because there have been some bug fixes that went into 8.0. Let me pull this up. So instead of main, try checking out release 8.0 or v0.8.0. Try this branch instead, because this feature branch that I'm on right now is based off of this. This is an unreleased version right now. That's the current release we're working towards. But it already has bug fixes and stuff that are in place. So main is basically synced with 0.7.1, whereas 0.8.0 has some fixes in it. So maybe some of that stuff in there would fix what you're running into. If not, you could also try the feature K-package branch. Try to keep that running, but let me know if that works. Notoki stuff. How's it going? Welcome. Okay. So this is static mesh, so we need static mesh. All right, and then instead of here, I think it's just asset name. And do we have anything else in here? Nope, that's it. So I think this is exactly the same, actually, between this type and height map terrain. So let's go ahead and do that. Oh, we're missing our scopulators. Okay, so this is going to be height map terrain. Okay, and then that's exactly the same. Water plane does not have any properties in need of disposal. Note, here to keep the compiler from bleating. Okay, so that is most of our types. The only ones that we need to handle now are the lights, which actually there's only 2 on each of those that are going to require releasing. Everything else doesn't really have to be released. So this is going to be directional lights, and then this is going to be, oh, wait a minute. That's right, we don't keep the string on this anymore, do we? I don't think there's anything to release on these. Nope. Okay, so actually, this one can be a little bit simpler. We can just do K0 memory. We want to do typed attachment, and then size of. That. Right? So we can do that here. We can also do that here. It's going to complain about the types because we don't have a closed scope. Okay. This needs to be a point light. And then point light here. Incidentally, those happen to be the same size, but that's probably not going to be true for forever. All right, let me just space these out just to make this a little easier to read. This needs a break. Okay. So there's our attachment destruction. Nice and simple. The only other thing that we have to do is destroy the actual array of attachments. So K free block is going to be node attachments, size of K asset node attachment times node attachment count memory tag array. Okay. Incidentally, I got thinking about this, what was it? Over the weekend, I think. And there's going to be a pretty large sweeping change that I'm going to wind up making. I don't know if I'm going to do it on this feature branch, or I might actually separate it out to a different feature branch and just wait till we're actually done with all this to do it. But our allocator, our internal allocator, is a lot smarter than it was when we first started the series. And so when we started this, we had to report the size of allocations that were being freed as well as the memory tag, right? So when we allocate memory, we have to supply the size and the tag. That's not changing. But what I want to do is when we go ahead to do a K free, I actually want to just look up the block of memory in an internal table and get the size and tag from that. And so I don't think it's going to require a whole lot of changes, other than we might store an allocation table instead of a free list, or maybe both. I don't really know. But we have the data that we need within the allocator to be able to handle this without having to require this to be passed everywhere. So it is going to be a pretty wide sweeping change. It's not something I want to do right now, but it's something I'm thinking about, because having to do this all the time is annoying. Live dangerously, merge all branches. I know, right? Yeah. You laugh, but at some point I'm probably going to do that. Not on purpose, mind you. Having the block metadata inside the allocator makes it a lot simpler to use. Yeah, exactly. Which means, unfortunately, everywhere that this is called in the code base, it's going to have to be changed. less error prone. And that's really the thing. It's far less error prone because I have freed the wrong tag before and it throws off my error reporting or my memory reporting. So in an effort to stabilize that, I'm going to wind up making that change at some point, probably before we release the first game. I might just do it offline though. Been there, done that, know the pain, yeah. Tested it, displays a lot of info null in console and FPS is very low. Okay, so I mean if it's writing info null to the console a lot, all the writes to the console is probably what's tanking your frame rate, first off. Why would it be writing info null though? Can you put a breakpoint on, where that's actually being called with the info level logging? Or just put like an if statement in the code or something and see where all those nulls are coming from? Because that doesn't, something is amiss there. I don't understand why you would be getting nulls all the time. That's really weird. I've not seen that happen before. Because info null is basically saying that whatever you're trying to write out to the console is basically you're passing a null pointer instead of a string. Ooh, side code, that's a good point. Yeah, this is not guaranteed to work in WSL. In fact, it probably won't. I didn't even think about that. I need to put in big bold letters, do not run this in WSL. Yeah, if you're doing it in WSL, then that's definitely the issue. Somebody else tried that too, and it was not good. Oh, you're not running. Okay, all right. That would have been an easy one. Big bold letters. Do not use WSL, period. Yeah. Yeah, not for graphics programming. I mean, yeah, I don't even know how that would work. Not fast, I would tell you that much. Okay. Okay, so our scene handler is all set up, actually. Let's see. We need to actually register it with the asset system. So, let's see. What did I... Known handler types. All right, we need to add it here. We'll include assets, handlers, scene. Okay. Here we go. Set up handlers for known types. So it's basically going to be a copy pasta again. Except for this one, it's going to be scene. And then we'll change the type to scene. Okay. So that is our scene asset handler, which actually wound up being pretty long-winded only because of the amount of serialization code that we have. But it is what it is. All right, to do. So scenes, done. Asset handler, done. Okay. So audio effects and music. This is going to be a little bit more complicated because I haven't fully decided how I want to do this yet. I'm thinking binary container format, but I'm not 100% sold on it yet. So I may actually tackle this in a separate phase and just read them from disk for now. I haven't fully decided on that, so I'm not going to touch these two yet until I have a little bit more time to think it out. Okay. I suppose this doesn't really need to be done right now. We could come back to this. This doesn't need to be done right now either. So shaders. Shaders is probably one that we could look at. So the first order of business is actually going to be our shader config files are going to have to change. And the reason I say that is because if we look at one of these, which I guess I'll pull up one of the ones in our new, let's see. This we could look in. Where are all of my other... I want these ones. Oh, right, they're all in runtime, I think. Because they're like core shaders. Yes, that's what it was. Okay. So shaders are a little bit of an interesting thing. So we have these shader config files. I guess I'll just open, let's see, what's one that we actually use? I guess we can look at the PBR static mesh one. Let's close this guy. So this is what the current shader config file looks like, right? It's kind of using our legacy format a little bit that we were using before, where we have this sort of almost INI like layout, file layout, right? And the cool thing about this is actually 90% of this is actually going to very smoothly transition to a KSIN layout, right? There are a few things that we're going to have to change up, but well, I guess it's not quite 90% because all of these uniform definitions and all of these are going to have to change format because we don't have anything that like takes this kind of a format right now. And we don't really want that, right? We don't want to have to like put notes in here and comments in here as to what each field means. So what we're going to need to do is essentially convert all of these files to a new KSIN format. So the way that we're going to do that is we're going to say the version of this is going to be 2. And then I guess what we could do is we'll retain enough of the old serializer to read the first line, essentially, and to say, hey, is the version equal to 1? If so, we're not supporting it anymore. I suppose I could make it a breaking change and just overwrite version 1 to be KSIN. I really don't want to maintain backwards compatibility for this one, actually. Because this will fail if you actually try to feed it into KSIN. You know what? Screw it. I'm not maintaining backwards compatibility for this one. We're just going to do a full conversion. It is what it is. Okay, so properties like this, version 1, that can stay. Name is a string, so that's got to be that, right? It's got to be surrounded in quotes. Do we want a name in here? I don't think we do, actually, because the name is actually going to come from the asset itself. I really don't want them to be different. I mean, this is kind of the fully qualified name, but again, that shouldn't be in here, because if we move this to a different package, then it's wrong. Which actually brings up another topic that I've been thinking about a little bit as well. Versions should always be 69 or 420. It might wind up being for some cases. Yeah, I don't disagree. Testbed fails to run if you run from the project root directory. Run it from the bin directory. Don't run it from the project root, run it from the bin. That could be half your problem, actually. If you ever need more than 2 versions, you start using combinations of these, like 420, 69, 69, 420. I don't hate the idea. I might do that with one of the other formats. We actually have, so we actually have in our asset types, we actually do have, we don't actually use the 64-bit one. I suppose I could leave it there, but we do have an asset magic number, which we put at the beginning of all of our binary assets to identify it as one of our assets. And I use Cafe Babe for that. Oh, you do the same thing? Yeah. I decided, like, if I was going to use a 64-bit one, it would be Cafe Babe Bad Coffee. Might have the same magic number files. That is pretty funny. I mean, I should have known that this wouldn't be unique, right? That's a widely known thing, but... Does Linux have something like Windows' hot reload? Yes. It does, yeah. It uses... I can't think of the name of it off the top of my head. What is it? Let me think. Dynamic. Where is it? Oh, you know what? I think it might be in. Might be in here. This is all threading stuff. Maybe it's not in here, actually. Oh, here it is. DL open. So it uses DL, right? So on Mac, it's like dilib. On Linux, it's just, you know. Hot reloading the entire game. Oh, yeah. So it does technically support that, although I haven't tested it recently in this refactor that we're doing. I would not be surprised if it's broken. But it does have the feature in there. It's probably just broken because the thing about hot reloading is if you have any function pointers in the library that are being hot reloaded, then they're going to be wrong. And that's why it would be broken. DL open and such. Yep, exactly. Yeah, it just took me a minute to actually find what the heck it was. But yeah, that's what we're using is DL open. Okay. So, back to this. I got thinking about this whole fully qualified name thing, and I'm not sure I want to stick with it. Here's why. So, if we go back to... Let me pull back up my diagram here. Here we go. All right. Let's see. Did I even put that in here somewhere? I thought I did. I guess not. Okay. All right. So I'll move over here to the side. So what we basically have for our what we consider a fully qualified name. I guess I'll make this really large text. Is we'll say we have package name, and then a dot, and then we have asset type, and then a dot, and then asset name. So for example, we might have something like, let me zoom this in a little bit because it doesn't need to be quite this small. Right. So for example, we might have runtime.shader.pbr static mesh, right? And that's what that might wind up looking like, right? In terms of when we request an asset, we say, I want the asset name this. And then when the asset handler looks at it, it says, okay, well, we know it's out of the runtime package, and we know we're requesting a shader asset, and the name of it is PBR static mesh, right? So that whole name thing that we had in the metadata, that's what those three parts split out to. The problem becomes, I got thinking about this, is what if the user wants to actually set up like folders, right? Which is something I hadn't really considered in this, that maybe might make sense to have. So what if in that runtime package, right, there was maybe I don't know, sounds, or let's go, all right, we'll say shaders, right? And then we'll say, maybe it comes with a few default textures, right, or images rather, it should be. And maybe it comes with, I don't know, some fonts, right? And then what if inside of that you wanted to say, well, I want all my PBR shaders grouped, and then I want all of my picking shaders grouped, right? Et cetera, et cetera, et cetera, right? So it wouldn't be very clean to then say, well, we have runtime shader, right? And then we have shaders slash PBR slash PBR static mesh, right? This is not clean. I don't like the way that this looks, right? But, you know, in order to support folders, we'd have to have something like that. You could switch up whatever symbols you used here, but the point remains, I don't know that I'm sold on this, right? And I got thinking about this, and it might make more sense to just have our asset API take runtime and shader, right, or the package name and asset type as separate arguments, in order to be able to, you know, handle something like this. Because then we can say, okay, well, you know, from the runtime package, right, I want to request a shader, right, and then at this path. Am I like out of bounds here? Let me see. There we go. Okay. So, you know, and then we can, maybe I'll shrink this down a little bit. Why? Okay. Wow. Tabs. See, God, why did it do that? All right. I don't know what the heck happened there. All right, so if we zoom out, then we might say, you know, asset system request, right? And it would look something like that. I don't know. I'm not going to try and like super format it here, but right. This to me feels a lot cleaner when you have a structure like this, right? The problem of requiring it like this is it requires a flat structure, which is fine for small projects, but on a really large project, that's going to make it hard to organize. I think you just need to use something like real path to the register the program's path and load DLLs from this path and not hard-coded. Yes, that is going to be configurable. It's just not yet. Yeah, that is, so we're, when we initially put all this stuff together, it was like kind of in a tutorial format just to kind of get things working. And that was one of the things that we did that way. And so we had some hard-coded paths, and that's why we're doing like the asset system overhaul and the way that all this stuff is loaded so that all that stuff's configurable. For example, assets me move this. There we go. So for example, in our manifest, I guess I could open, it doesn't really matter which one I open, I suppose. Do this one. If we wanted to, right, this doesn't even have to be like our material column C, right? Doesn't even have to be relative. On Windows, we could literally do, something like that if we wanted to. Obviously, you wouldn't want to release that way, but probably what you would want is a scenario like where you have source path equals, right, and then you might have C, users, etc., whatever, whoever the user is, right? I'll put Travis, and then work assets column C dot MTL, or whatever the source path happens to be. And so there's this is configurable for assets. There's no reason that it also couldn't be configurable for hot reloading as well. Let me undo that. The other thing is we do have this this application config, right, which has, this is probably the place where that would exist. Okay, so we have like a base asset path. This is probably going to wind up going away, but for now we have it. But if we look a little bit further down in our systems, we have our plugin system, right? So these plugins, right, this is what causes the DLL to load. So we could very easily also include a path in here, or a relative path or an absolute path, to say where to actually find that. By default, it looks in the bin folder, or the folder next to the executable, where it's actually being run from. But then, we could override that potentially. So I hope that makes sense. But yeah, this was part of what we were doing to get away from all that hard-coded stuff. So we're making it configurable. So yeah, it's in progress. It's just not done. Okay. All right. So anyways, back to this. So I'm actually considering like changing the API to just not do this anymore, and just go back to assets, just having a name, and not being concerned about what package they're in. The only weird thing about this is if we have, and part of the reason I did this is assets that rely on one another, right? So if we have a material file that relies on a texture that's part of a different package, how do we resolve that? Do we search the other packages for an asset name that? What if we have two packages with the same asset name? And I suppose our manifest could potentially handle some of that with the references, right? We could say, well, we can only reference these packages. Fine. But even within this scenario, we theoretically could have a shader, for example, that exists both in runtime and the plugin standard UI. Now, obviously, for like Kohi official plugins or libraries, like I wouldn't do that, right? I would make sure that there's no collision there. But for user libraries, there's not really a way to do that. So if we were to switch to this, to just have, this type of thing, we would have to have some sort of way to be able to specify package as well. Or we could always just have the rule that you can't rely on assets in different packages. That's the other thing. Which, I don't know how I feel about that. And that's only a reference from one asset to another, right? So like obviously the scene could reference that, be just fine, but we have ads. So yeah, it's definitely a problem that's going to take a little bit of thought to get around. For sure. Stretch a little bit. I think I've been hunching over. Almost done with ads. Well, we got 45 seconds left. All right. I'm just trying to think. While preventing cross-referencing sounds like reasonable, I wonder if it could hurt user assets in any ways. It's a tough call. Yeah, exactly. Like I would hate to like put in that restriction and then later really regret it, you know? All right, ads are dead. So yeah, it's like, which direction do I want to go with this? Like if I have an asset that loads or that references another asset, do we have two fields maybe? Where maybe you can specify a package name, and if a package name isn't specified, then it just finds and uses the same package, or the first package that has an asset of that name and uses it. That's the right type. Maybe that's the way we go, actually. So if you don't specify it, if you don't specify a package, then it says, okay, I'll search all the packages for a asset of this type with that name. And the first one it finds, it just uses. And if you have a different package that you want to use, specifically, you could specify the package in the asset. Is anyone else noticing how little the stream latency is now? Feels nearly instant. Never seen it this good on Twitch. Not sure what changed. Oh, that's pretty cool. Kind of like an import per referenced assets. That sounds like a good idea. Yeah, I think that might be the way. You know what? I'm going to write that down because I'm going to forget it. So redo this. We're going to say asset handler. Stop it. Request. And then we'll say package name, asset type, and then asset name. Assets that rely on other assets can optionally specify a package name. VFS will first look in the same package for a asset of the right type with a matching name. If not found, then iterate all packages looking for one and use the first one found. If more than one package contains such an asset, the user should specify the package in the asset reference. Okay. That way I don't lose that. Optional package name specifier. Yeah. I think that makes sense. And that seems relatively foolproof. It's got a nice, reasonable default, so you don't always have to provide it. But a backup in case you need to. I think that's fairly flexible. Okay. So, doesn't lose functionality and also doesn't overly complicate things. Exactly. In fact, it actually simplifies it a little bit because you don't have to worry about this crap anymore. So that is actually, I think, exactly what we're going to do. I don't know that I'm going to tackle that portion tonight, but yeah, we're going to get rid of a fully qualified name. That's not going to be a thing anymore. Before I forget to bring it up again, because I know there's a lot more of you in here now, on our Discord server, we actually have a vote going on that I would like you guys to take part in, if you don't mind. What is your preference of the first game made with Kohi? Now, you know what my vote is, right? But there's a small arcade-style game, but in 3D. Looks like most of you guys are going for that one right now. Screw it. Start making the big game. Or neither, just keep adding stuff to the engine. If you guys could go in there and vote. The polls are open for 2 weeks on that. And there is a thread right below to discuss it. If you guys could vote on that, that would be great, because we're kind of getting to the point where we need to start thinking about what kind of game we're going to make. And I think an arcade game would be easier rather. But I kind of want to make the big game too, right? So we'll see. We'll see what you guys say. Right now it's not favoring that, but that's okay. You know, whatever the votes actually come out to be, that's what we'll stick with. All right. In fact, there's the link to the Discord for you guys. I'll put this over on the YouTube side too. All right. So now we need to circle back to where we were, because this is going to be a big thing. But we just finished the asset handler for scenes. So I guess the next one that we could start looking at, I think we're going to start looking at shaders. Oh, we're converting this. That's right. Okay. So we were talking about what this would look like, and this is actually what brought up that that whole conversation because of the name, right? So we don't actually care about this. We don't need name. The name is the name of the asset when we actually load it. Like, the name is here, right? I think we also did say, though, we want to name this KSC for Kohi shader config. So let's actually do that as well. So KSC. So for Kohi shader config, right? Let's just kind of standardize our file names a little bit here. All right. So the next thing that we have to look at is stages, right? So we're obviously this comma format's not going to work anymore. So in this case, let's actually make this an array. And we're going to say vertex and fragment, right? And so that's stages. The spacing doesn't really matter. Our parser will handle it. It's just a little easier to read if I space it out nicely. Okay, so actually we have stages and stage files, right? We could actually combine these two because our old format kind of required that we just line the arrays up, but we don't really have to do that anymore. So we could actually say this is an array of objects, right? So we can do this, right? And tab these over as well. So we'll say in here, here's the name. Or actually, no, this is gonna be the type, right? So this is gonna be type. And then I guess we'll say source file. Source, no, let's go source asset, right? And so we'll do this version, or this portion of it. So we'll do that portion of the name. So that's the name. You know, and if we wanted, we can include folder information here. So we could say like, we could even do PBR / right? And then we could also do, should we do package or package name? Package name, I guess. Runtime. Right? Now, now this will actually know what package to look at, so it doesn't have to scan them all, and where to load it from. And the way that we're going to do this, the way that we're going to store this internally in the manifest. So if you take a look at the runtime manifest, which one are we doing? PBR static mesh. So that's going to be this one. It's not behind my noggin, right? Yeah, okay. So the way that we're going to do this one is we're actually going to rename the asset to this, right? And we're going to put the / in there. So folders as such, I'm thinking probably won't exist. Or maybe they do, right? Maybe we do this. PBR, right? And then we do type equals folder. If I do this, you know, the folder technically isn't an asset, but we could include metadata with it if I do that. And I suppose we could actually modify this a little bit if we really wanted to. We could, in theory, do this. Right, and then we don't have a need for this. It would look something like that. Right, and then the path on disk would be, right, we'd probably edit this to be something similar on disk, right? This would have to be, what did we say that was going to be KSC? Right. So we could do something like that. What do you think about moving to Meson build system? Because there's a lot of build scripts that I think are harder to maintain. Well, okay, so the build scripts that we have in here, I actually need to do some maintenance on. Because I kind of built them a long time ago and just forgot them and just kind of keep adding stuff to them. We actually are going to write our own build system in C. We are going to explore that. And so eventually I want to eliminate the dependency on make as well. And only have a dependency on our compiler and Vulkan, essentially. So the goal with that is to basically, I want little to no dependencies. So I don't want to like introduce a build system that has then dependencies, right? Because then you have to have that build system installed. I don't want to do that. I basically want to say our dependency is C, and and maybe you have to have like this SDK installed for like Vulkan. There's no way around that. And then on Linux, obviously for windowing libraries, you'd need some of that stuff, but that's everything in Linux, right? But yeah, I would like our C build system to be written in C as well. Your vote counts for 50. You'll swing things back into big game. Nice. That'd be hilarious if I could actually weight the votes like that, but it would also skew things like crazy. For 2D, how do you handle sprite batching? So we don't actually have anything in 2D right now. So the way that I intend to handle sprite batching, though, or batching in general, is we're going to, as far as our renderer knows, our renderer doesn't know anything about sprites versus meshes versus any of that stuff. All we tell our renderer is, here's a segment of the vertex array to bind. Here's a section of the index array to bind, and then draw these indices. And we did it that way so that we don't have to worry about that stuff in the renderer, right? Our renderer is basically super flexible because of that. So when it comes time to batch stuff, it gives us a lot of power on the application side, or maybe even on the engine side, to handle that. So when we do batching, our batching is also not going to be specific to the type of data that we're dealing with. Our batching is also going to be relatively or as agnostic as possible of the type of data. Using SDL right now without any hardware acceleration, but thinking about supporting an OpenGL backend. Do it. Yeah. Worth it. Thank you guys for the follow, by the way. Appreciate that. Yeah, I would highly recommend doing that. Yep. And, we abstracted things in our renderer so that, A, we don't want the rest of the engine understanding that Vulkan is being used. We don't want it to know or care. And B, we can slide in any other graphical backend, right? So we have a front end and a back end. The front end is what the rest of the engine interfaces with, which is render API agnostic. So if we wanted to write an OpenGL backend, we could. We're probably not going to be doing that here. We're probably going to use, we're definitely going to use Metal and probably DirectX as well, Direct3D. But yeah, we kept things agnostic that way. We don't have to worry about that. So something like sprite batching is actually not something that we're going to do in the Vulkan layer. It's actually something we're going to do in the renderer layer, or maybe in a different layer outside of that. All right. Looks like somebody over on the YouTube side actually asked the same question about 20 minutes ago. Sorry, I missed that. It's kind of buried in the Streamlabs spam there. I might have to adjust that on the YouTube side. But yeah, if it, 2D or 3D, it's all 3D. But as far as the renderer goes, it doesn't care whether it's 2D or 3D. It relies on the application to tell it. So the engine itself is actually agnostic of that. Everything we do right now is 3D, but it doesn't have to be. You could easily set up your application to do 2D only. Is KSC custom scene file? Yes. So the scene file is, KSC is the shader config. KSN is the scene file. So scene file is looks like this. That's a basic scene file. KSC generates GLSL? Probably no. So the it's a shader config, and what that means is it essentially sets up what we're going to need to actually build all the resources we need for a particular shader. So we put information in here like the source assets. So we have in here PBR, static mesh, frag, and vertex. These are the GLSL files, right? So those are that's the actual shader code. So in here we have a reference to that. I'm actually converting this file format right now to something different. But yeah, basically the way it works is this file gets loaded by the engine, and then it picks out these source files, right? So let me finish putting this in here, so it looks at least somewhat consistent. So this is the fragment, right? So for the vertex stage, we use the vertex shader. For the fragment stage, we use the fragment shader. They both come from the runtime package. That gets rid of that. And then we have things like, is depth right enabled? Do we support wireframe for this? Because we have to set up different pipelines for that. The max number of instances of things we can draw with this. So in this case, it's 256. We'll probably wind up bumping that number up eventually. But it basically just stands for how many resources we actually stand up in the GPU to allow for instances of things to be drawn with the shader. And then we have, our shader attributes, right? Like, so our position, normal, text chord, all those attributes that you have in GLSL. And then our uniforms here at different scopes. So if we actually take a look at the GLSL, let's look at the vertex shader first. So we see here that we have these attributes up here that are in the same order as they are here, right? So that's not a coincidence. This is the order that they appear in the shader, right? So we don't have shader reflection yet. I might write that eventually. So this is basically telling our application, hey, this is the setup we have, and this is what the shader expects. So this is like metadata for the shader itself. Eventually, like I said, we'll probably have some sort of reflection in there to handle this stuff a little bit more dynamically, but that's really complicated. So anyway, you're using C++20. Isn't memory management hard? No RII, inheritance in C. Makes things much simpler, actually. Much simpler. In C++, I always manage my own memory anyways. I always wrote my own allocators. I don't use, the STL or anything like that. I write my own containers, all that stuff. But yeah, C is much simpler language, right? And once you get used to it, you'll find quickly how much simpler and easier it is to work with. C++, especially modern versions of it, are super complicated. I'm not a fan. Memory management is a must for performance software. Yep, exactly. C or C++. Yeah, it doesn't matter which one you're using. You're going to want to write your own allocator. Also easy to bind your engine API to other languages. Exactly. Yeah. I've got some people that are interested in writing Zig bindings for it eventually. Which, I mean, right now Zig can just compile against C libraries anyways, but I think somebody even said Rust at one point. Okay, so now we can actually use Booleans in here, right? So we can say these things. Supports wireframe true. All right, so our attributes are going to require a little bit different of a format, right? Also, our comments need to change. We need to change these to JSON style comments. So let's go with our attributes. Let's do attributes, and we're going to have an array of these. And each one of these is going to have the properties that we have here, right? So we're going to have type equals vec3. And then I guess before that we should probably do name. So in position, right? Actually, that's all we need for attributes. So we can just put these in. I'm just going to copy pasta that a few times. So we want normal, which is also a vec3. If I spell normal correctly, anyway. The next one is text chord. That's a vector2. The next one is color. That is a vector4. And then tangent. that is also a vector 3. We probably need to like rethink some of those and like round that out to maybe use all vector 4s and then just use the extra properties for, compact things a little bit more. But for now, I'm not going to bother. That would be a breaking change. All right, so that's attributes. Uniforms are going to be kind of the same deal. So for scope right now, scope is basically, you can think of scope as how often that particular uniform gets updated. So global is basically a one update per frame, right? So that's things like your projection matrix, for example. Instance is, you can think of that almost as per material, right? So you've got properties that get set sort of per material, but you might have multiple objects that use that material. And then local is every single draw call, right? And so we can actually make this a little bit more expressive. So we don't need this comment anymore. And we don't need this one anymore. What we can do is uniforms. And this is also going to be an array. And so we'll do the first one. The first one is going to be have a name equal to projection. It's going to have a type. And that's going to be mat4. And it's going to have a scope. And instead of saying 0, 1 or 2, while that might be easier to parse, I think it's less expressive, right? So we're actually going to go global with that, right? We're going to use the string representation. It's not going to slow our parsing down. It only happens at shader load anyways, so I'm not really worried about it from a performance perspective. It's not going to be prohibitive, right? So let's see. We've got a whole bunch of uniforms, so we basically have to just convert all of these, right? So I'm just gonna, I don't know, let's do like 12 more copies of that, right? And then I'm gonna also open that file over here. So we'll do PBR static mesh KSC, just so I can kind of see the properties next to where we're working. Here we go. So the next thing we have is views. Right, and this is actually a mat4 array with 2 entries in it. That one's also global. We have light space 0, 1, 2, and 3. I think the shader for that. Not PBR shader, PBR static mesh. I think the shader for that actually is an array. Okay, so let's update that. It's an array of 4. We have this sort of hard-coded in here. So instead of having them be split out like this, let's actually just combine them into one and set it up as an array. We did this on some of our other shader configs, just not this one apparently. So we'll say light space, space. Actually, we'll say light spaces. And this is a mat4 array of 4, right? And that's global as well. Then we have a cascade splits, and this one is a vec4. And then we have view positions, and this one is a let's see, a vec4 array of 2. And our parser, by the way, is smart enough to pick up that this is an array type, right? So we already have that functionality here, so we can leverage that. Next thing we need is mode, and that is a U32. Global as well. All of these next things are going to be global. In fact, yeah, this one is also a U32. This one is use PCF. That's our filtering for our shadow maps. Our bias for our shadow bias, that is a F32. And I believe the next one's also an F32, which is padding. So not used, but used to bring up ads. Taman, how's it going? Good to see you. Use C++ because of templates and namespaces? Bleh. I don't use either. Namespaces make the code more elegant. Just personal preference. Fair enough. Hardly something I would switch to C++ for, though. Analog for templates can be done in C, but with a lot of pain implementing them and a lot of pain while using them. Fair. You can use macro shenanigans? Nah. I mean, the only macro shenanigans we use is for a dynamic array, but we avoid that for the most part. No compile time, hard to type check. That's fair. Well, okay though, but like for the dynamic array, we actually got around that too. It's one horrible point about templates in C++, compile times get absolutely out of control. Yup. 100%. So regarding that, in our D array, right, we have sort of this underlying function that we use, right, that just basically takes a length, a stride, and potentially a frame allocator, right? But we later then have a macro, right, that creates it at default capacity and then grabs the size of the type, right, and just casts it back to type. So when we do this, we make sure that we don't have a mismatch in type. So there are ways to do it. All right, so that's view positions, mode, use PCF, bias, padding. Okay, I think that is it for the global ones. All right, so material textures. This is going to be a sampler 2D array of 3. Wait a minute. Yeah. Yep. Okay, and then scope is instance, which actually that's true for like the next several. So I'm just gonna cheat and update those now. All right, so the next one is shadow textures, and this one is a sampler 2D array, which is instance, and then IBL cube texture. This is a sampler cube. That's instance. And then we have a directional light, right? Which in our case is a special struct 48, right? So our parser is smart enough to also say, if we see the keyword struct here, then this uniform is a struct, and here's how many bytes it is, right? We might be able to make this a little bit more robust in here, but for right now, that still works just fine, I think. So let's see. So the next thing we have is P lights, which is point lights. And so that is another struct. That's actually an array of 10 of those. So that's actually going to be struct 480, right? Because we're passed through up to 10 of those. And that's also instance. And then we also have properties, which is just other generic material properties. And this is a struct 32 instance, right? And then last for that scope, we have the number of P lights. So that is going to be, I think that's just it. Yeah, it's an I32, right? And so that's the last one that's instance level. And then finally we have some local level ones as well. So we have the model matrix, of course, which is MAT4. And this is local. Right, and then we have, whoops, that should be model, not mode. And then we have clipping plane. That's for our water, right? That is a vec4. Yeah. And then finally, we have a view index. View index, and that is a I32 as well. And that is local. Okay? And so that is basically what the new format looks like. So we can get rid of all of that. We can close this. And that's essentially what our files are going to look like. Now, more than likely, I'm not going to do all this by hand. I'm probably going to write some sort of utility to convert all these for me because there's a lot of them. Enough that it's probably not worth doing by hand. So that's kind of what we're looking at. But this is the new format of kohi shader files, right? So I think between that and what we are looking at here with changing from this basically to this, just as a reminder for myself, right? Moving away from this format of names to just handling it this way, and then dealing with pathing. I think that's going to be the way to go. So we'll have to implement those changes. We've got to convert all of our shaders. We have to write a asset handler for our shaders, and a serializer, deserializer. Actually, I don't know. Well, yeah, we probably do need to go ahead and write a serializer as well. We definitely need a deserializer to read this in. We won't use the serializer right away, but eventually we're going to have a shader graph that's going to write this stuff to file. So that is something that we don't have yet, that we are going to have at some point. Okay. So, I think this is actually a pretty decent place to stop. Let me just, oops. Okay. But let me make sure that we build first. Nope. Okay. Oh, right. Because it changed asset type. Asset system looks like it. System. That's right. I forgot we had the asset type in there twice. Should just be that. We had it duplicated, and we don't need to do that. So I think there were 3 instances of it. Try not to check this stuff in if it's not like actively building. Okay. In theory, this should still run, because I don't think we've actually screwed with any of the existing assets yet that are in the existing structure. So it should still run, and you guys should still be able to look at stuff. We'll see. I don't think I've broken anything. Yeah. Okay. So Oh yeah, I forgot to mention this actually. Cool little visual update. I actually played around with the water shader a little bit more. I'm not done with it quite yet, but it looks a lot better, I think. And I also added sort of a wetness factor to materials that are below the surface of the water. And I actually need to add like a specular override for it as well. But you'll notice that they're a little bit darker, as would happen with a wet material, right? So I do need to increase the specularity of things that are underneath the surface of the water, but I think that it looks a heck of a lot better with that in there. We'll just look inside the Sponza real quick as well. Right? I think it just makes it look a little bit better. We've entered the build error part of the stream. Brace yourselves, it's about to get bumpy, but it's not. Unless you count the bumps on the water surfaces. Let's see. I'm using a custom scene loader that can generate objects from that. Can also generate scene file from render objects. Nice. The gods smiled upon us today, they had mercy. Well, we're not using any of the new asset stuff, right? We're still loading using all the old resource stuff. So when we start ripping that apart, that's where stuff's going to break. Horribly. We're not there yet. Because this whole asset redux is only half the battle. The other half the battle is the resource system has to have an overhaul too. To utilize the new asset system for lookups and things like that, but also to handle the jobified loading process from the VFS. Because right now it doesn't do that. It basically says, all of our loaders say, hey, file system, give me something and I expect the result right now. Not, hey, you can just do this asynchronously and get back to me when you're done. Big difference in how those two work. So we'll handle it though. All right. So it is getting a little bit late for tonight. So I think what I'm going to do is I'll go ahead and check this in, I suppose. Let's see. Right, so here's all the stuff that's changed. It's commits, work in progress, asset system. Yeah, I pushed some water fixes before. More importers and binary serializers. Really, we have scene, asset, handler, and serializer. Let's see what else is in here. Added vector type parsing serialization to KSON parser. Yeah, that's descriptive enough for now. All right, so that stuff is all pushed to the feature K package branch if you guys want it. Because that's what we're working out of right now. Let's see. Which technique am I using for the water reflection? So we're doing it the old school way. We're using planar reflection for that. Where basically the whole scene is rendered 3 times. Well, not the whole scene. The scene within the camera's frustum, right? Yeah, planar reflection. Yep, exactly. So, yeah, we just we load the scene once from above the water with a clipping plane at the water level and load everything below it for the refraction. Render again from below the scene, facing upwards for the reflection, with the clipping plane only rendering above the water. And then we render the entire scene with the surface of the water using those 2 textures that were previously rendered. Does the engine support physics? Not yet. No, we don't have that yet. We are going to need that at some point. And depending on whether or not the first game requires it or not, depending on what we decide, will depend on when that goes in. Recently started using LazyGit plugin for NeoVim. It is actually great. Helps manage commits. I don't know. I'm just old school with the command line. I don't know. I don't like most of the GUI Git managers. The only thing that is nice sometimes is using them to diff, but that's about it. Anyway, let me pick somebody to raid. Like I said, I do have to get up in the morning, so for work. Let's see. Who is doing cool things? Let me just see if I can find somebody to raid real fast. You know what I haven't done in a while, actually? And I like to support this whenever I can, so I'm actually going to we are going to raid Ovea Sanctuary. So they are a nonprofit sort of animal rescue / sanctuary. And it's run by really awesome people, and I like to support it whenever I can. And just having the stream up supports them. So I do like to support that every once in a while when I can. So that's what we're going to do tonight. And we will be back tomorrow night around the same time, around 9-ish Eastern Daylight Time. And we'll continue working on this stuff tomorrow night. So thank you all for being here. I really appreciate you. Appreciate you interacting, chatting and stuff. And we will see you guys tomorrow. If you haven't already, by the way, I would really appreciate follows and or on the YouTube side, subscribes. It helps me grow the channel and reach more people. So thank you guys. I appreciate it, and I'll see you next time.